Hi everyone, can you all see the whiteboard?
Yes.
Yes.
Let's get started with the first question. What answers did you get? Okay, good. 49 over 64 is correct. Ishan, can you explain how you got that?
Yeah. So first, the I just put into 8 parts of like parts, and then I took out one part because they served the orange juice, and then added another part of water. And then each part now has 7/8 pure orange juice and 1/8 part just water. So I just did 7/8 minus 7 over 64, and I got 50.
Good.
56 over 64 minus 7 over 64, which gets you 49 over 60.
Good. Yeah. So this works. The idea is basically you know that initially you have 8 quarts of orange juice. So the first time you do this procedure, 7/8 of it is now orange juice, and then the second time when you remove 1 quart of the beverage, you remove 1/8 of the orange juice that's there. That's 1/8 of the 7/8 that was there, and you can subtract that from 7/8, and you get 49 over 64. So another way you can think about this is also, so if you look at the total amount, in the cup, there is orange juice and there's water, right? So initially there's 8 quarts of orange juice. The first time when 1 quart is removed, so you only have 7/8 of that is now orange juice. So there's 7 quarts of orange juice. Now the third time you do this, 1 quart of whatever was there is removed of the total, which is a mix of orange juice and water. So 7/8 of the mixture remains. So that means 7/8 of how much of our orange juice was there also remains. So 7 times 7/8 is 49/8 quarts of orange juice. So now 49/8 is the total amount of orange juice, and there's still a total of 8 quarts in the container. So 49 over 8 divided by 8 is 49 over 64, which is the fraction of the final mixture that is orange juice. Does this make sense? Any questions? Okay, let's move on to the next question. Okay, I see a few different answers. 1/3 is correct. Pavan, can you explain?
Yeah, so first we have to realize that there's four types of cubes you can have. You can have one cube that's in the center, like you can't even see it. It's not possible for that to have any paint on it because it has 0 colors. Then there's one thing that has 1 color, and there's a 5/6 chance that can like have a color. And there's 6 of those pieces. And then there's also a cube with 2 colors, and that has a 1/3 chance of falling on the painted to having only one visible side, and there's 12 of those. And there's also a third cube with 3 colors, but that's not possible because there has to be at least 2 sides that are visible. So we just do 5/6, since that's a probability for the one colors, times 6/27, because there's a total of 6 cubes with only one color and a total of 27 cubes. So 5/6 times 6/27, and then you add that to 1/3 times 12/27, because there's 12 cubes of two colors and 27 total. And when you add it up, you get 1/3.
Good. That's correct. So let's go through this a little more in a little more detail. So let's see. First, let's understand what are the types of cubes when you break this up, and let me see if I can draw what this would look like so that it's hopefully clear. Okay, it's not fully symmetric, but hopefully good enough for to see these. So first, let's look at how many faces. Once I paint this 3x3 cube, I'm going to split it into 27 cubes along these lines that I have here. So we want to see how many cubes there are with different numbers of faces painted. So there's one cube that's in the middle of all this, somewhere behind this one and this one, inside. So when I break it into 27 cubes, that one is not going to have any face painted. There's nothing of it that's exposed. Now the next one with one face painted are these cubes. One on this face, one on this face, one on this face, and there's 6 of those. So 6, they're like the centers of each face. They each have one face painted. Now what about cubes with 2 faces painted? So that's like this one. It has this face and this face painted, similar to this one, this one, this one. So it's kind of the center of each edge. So there's a total of 12 of those. You can count on this picture. So 1, 2, 3, 4. There's 4 on these centers and 4 there on the other side. So 12 of those. And the cubes with the most faces painted will be these corners. So the 8 corners have 3 faces painted. Now let's think about what we're being asked. So we pick one of these cubes randomly, which now we know can have either 0, 1, 2, or 3 faces painted. And when you roll it like a dice, you want the probability that exactly one of the 5 visible faces is painted. So once I roll it, we have a die sitting on a surface. So in this cube, there's 5 visible faces. So there is the top, these 4 sides, and only the bottom one is not exposed. So of these 5 visible faces, you want the probability that exactly one of the faces is painted. So if exactly one of those faces is painted, what are the possible choices for the total number of faces painted in this cube? Could it be 3? So let's imagine if there were 3 faces painted, one of them could be on the one below, but 2 of them would still be exposed. So of the 5 visible faces, 2 of them would be painted. So it's not possible for this cube to have had 3 faces painted. So 2 or 1 will be possible, and 0 clearly cannot be possible, right? Because we want one of the faces to be painted. If the cube had 0 faces painted, this is not possible. So we know that, okay, the cube that I pick has to be either the one with 1 face painted or 2 faces painted. So first, what is the probability that I pick a cube with 1 face painted? So there's 27 total cubes. 6 of them have 1 face painted. So this probability is 6 by 27. Now, once I pick this, in most cases, it'll land such that this face is visible. But in one case, this one face that's painted could actually end up on the bottom here, and it wouldn't be visible. So what is the probability that the one face ends up at the bottom?
One-sixth.
Good, 1/6. So the opposite probability is 5/6 that it doesn't end up at the bottom. So if I multiply this by 5/6, that's the probability that it's still visible. So this gives me 5/27 is a probability that I chose a cube with one face painted, and exactly one of the 5 visible faces is painted based on that. Now the other case is that I choose a cube with 2 faces painted. So that there's 12 of those cubes out of the 27, but now that's a little bit trickier because now I need one of those faces to actually end up at the bottom so that it's covered, and then exactly one of the 5 remaining faces will be painted. So what's the probability that each of these cubes have 2 faces painted? What is the probability that one of them is not visible?
Two-sixths.
Good,
Or
2/6. Yep. So one of these 2 has to end up at the bottom. So there's 2 choices that could be at the bottom out of the 6 possibilities. So 2/6 or 1/3. Let's multiply this by 1/3. And we get 4/27. So the answer will just be then adding up these 2 values. So 5/27 with starting with a cube that had 1 face painted, 4/27 starting with a cube with 2 faces painted. So this probability should be 5/27 plus 4/27, which is 9/27 or 1/3. Does this make sense? So the key step here first was looking at this 27 cubes and thinking about, okay, how many faces of each of these cubes are painted? We know that when we paint all the surfaces, all the outside surface of this, and then break it up into cubes, not all the cubes are the same. So you have to figure out how many faces are painted on each one, and then think about, okay, how should the cube land such that exactly one of the 5 faces is painted, and then we can compute the right probabilities. Any questions on this? Okay, let's move on to the last question. Okay, good. 7 miles is correct. Pavan, can you explain?
Okay, yeah. So since we're traveling at the same speed, the point where they'll stop the trains is at 5 miles. So each train's only going to travel 5 miles. And since they're going 50 miles an hour, it's going to take them 6 minutes to crash into each other. But you also have to realize that the bee is going to keep on flying until they keep on crashing. So the bees just, all you have to do is just find out how far the bee goes in 6 minutes, because it's going to keep on going until they crash. So I just did 70 times 1/10 and you get 7.
Good. So let's first just think about pictorially kind of what happens here. So you have this station A, station B, and the trains are moving towards each other. And so starting off, the B starts from A, it moves towards B, then it hits B somewhere in between, and then it moves back towards A, and so on. It kind of moves this way back and forth until eventually the trains come close and pass each other, and then it stops. So it keeps going back and forth. So if I actually had to calculate each of these, this can go on infinitely, right? I can keep going. It goes from A to B, B to A, and they just keep getting closer and closer. So it's a little bit messy to think about if I had to add up each of these. But the kind of trick here is that the B is always moving at the same speed. So it started going this way, then it went this way, then it went this way, and so on. It's always still moving at 70 miles an hour. So all I really need to know is how long did the bee fly for? And it's flying starting from the time it left, both the trains left their stations, until the time that they pass each other. So they reach the same place, it keeps flying back and forth. So we don't really care which direction it was flying, as long as it's flying, it's moving at the speed 70 miles an hour. So all we really need to know then is how long did it take for this train and this train to meet? So they were originally 10 miles apart, and they're moving at 50 miles an hour towards each other. So essentially they're moving at 100 miles an hour. Is the rate, the distance between them is shrinking, or like if you consider together how they're moving. So for the together to make up for 10 miles, it's 10 over 100 of an hour, or 1/10 of an hour, is the time it takes them to meet. So if the bee was moving at 70 miles an hour for 1/10 of an hour, this would be 70 times 1/10, or 7 miles for the total distance traveled by the bee. So it becomes complicated if you try to think about, okay, how long did it, or how much did it move the first time, the second time, third time, and so on. You can also do it this, and you'll find that this series will also add up to 7. But the easiest way to think about this is just how long did the bee travel for? And we know that the speed it travels is this constant 70 miles an hour for 6 minutes, or 1/10 of an hour. So it in total moves 70 times 1/10, or 7 miles. Any questions on this?
No.
Okay, then that's it for today's class. We'll see you all next week.
Thank you.
Thank you. Thank you.